Today's video talks about functions and their input-output tables. So if we look back at what a function is, we know that every input has exactly one output. So if we look at this table and recall this, inputs, independent variables, and domains are all the same thing. This is the new one. Whoa, that star went a little crazy on me. Independent variable and dependent variable. Please make sure to write those two down in addition to your previous function notes. So remember, every domain has one and only one range. Like in number 2, if it has 2, it is not a function. So, for example, a function is where you put in something. So like, for example, 2, I'm going to put it in the function machine, and out is going to come a 5. So that's my output. If I input a 5, 8 comes out. If I input a 4, a 7 comes out. So what's the rule here? Do you see anything that's going on between these two numbers? You could say add 3. Does that work each time? If I add 3 here and I add 3 here, is that the common rule? The rule is definitely, in this case, add 3. Let's look at another one. If I input 5, 2 comes out. If I input 7, if I input 7, 4 comes out. If I input 8, 5 comes out. So we've got 5 becomes 2, 7 becomes 4, 8 becomes 5. In this case, we're taking 3 away. Take 3 away, take 3 away, take 3 away. So whatever you do to your input, you have to do to each and every one, so that way your outputs maintain that consistency. So if you notice here, every one is a subtract 3. What about this one? Let's try it and you see if you can figure out this one. So if I input 2, I get 4. If I input 4, I get 8. And if I input 5, I get 10. What do you think the pattern is? Go ahead and try it. Okay, if you want to pause the video before I show you what the pattern is actually multiplying by 2. So if you take 2 times 2, you get 4. 4 times 2, you get 8. And 5 times 2, you get 10. What if I input 10? What would I get? 20. What if I input, 8? What would I get? 16. You're multiplying by 2 for each input. Let's look at this one. Excuse me. If I input 10, 21 comes out. If I input 6, 13 comes out. And if I input 7, my output is 15. See if you can figure out what this one would be. Sometimes there's multi-steps. For example, there's something going on here, but it doesn't necessarily happen all the time. Like, for example, we're multiplying by 2? No. But if we multiplied by 2, we get 12, and if we add 1, we get 13. If we multiply by 2, we get 14. If we add 1, we get 15. And if we multiply by 2 to get 10, and we add 1, we get 21. So sometimes it has 2 steps, not just 1. So in this case, you first multiply by 2, and then add 1. Let's look at this one. If we input 6, we get 11. If we input 7, we get 13. Oops, I forgot to write that one. 11, 13. And if we input 10, we get 19. So when we look at this, in this case, we are doubling them. So like 6 times 2, but we're taking 1 away. 7 times 2, but we're taking 1 away. So again, with this one, you're multiplying by 2, but you're subtracting 1. So these are called function rules. They tell you what to do to the input to get your output. For example, in this one, you're going to multiply your x by 2 and add 3, and it gives you your y coordinate. This is typically how we see functions in algebra. You might also see it in function notation. This is equation form, and this is function notation, where you see f of x and it equals the same thing. This y and this f of x both stand for your output, while x right here stands for your input. So if we look at this one, if I plugged in x, 2 times x is 4 plus 3 would be, 2 times 4 gives me 8 plus 3 gives me 11. So if I input 4, my output is 11. Let's look at some more examples. For this one, if you have the f of x equals 14 plus 3x, find the value. We want to plug in a negative 7. So the way we write this is 14 plus 3 times a negative 7 equals my f of negative 7, or my f of x. So if we do this one, 14 plus a negative 21 gives me a negative 7. So f of x equals negative 7. If we look at this one, okay, somebody came in, so I had to pause the video, but I think I was right here. So f of x equals negative 7. So really, if we thought of this as being y equals 14 plus 3x, your output is negative 7. So when you have an input of negative 7, your output is also negative 7. This is a pair of points on your coordinate plane. Okay, so if I input 4, 14 plus 3 times 4 gives me 14 plus 12, so that gives me 26. So when I input 4, my output is 26. Again, this is a coordinate pair on this particular graph. Okay, so let's look at another example. What I mean by that are that all the points on a line or in a table are solutions to the equation. So, for example, if we take and we look at all of our x's in this one, these points, these outputs, are points on the table. So, if I put in negative 5, 2 times negative 5 gives me negative 10, minus 8 gives me a negative 18. If I plug in 0, 2 times 0 minus 8, this is 0 minus 8 is a negative 8. If I plug in 2, 2 times 2 is 4, minus 8 is negative 4. If I plug in 4, 2 times 4 is 8, minus 8 is 0. So if I were to plot these, x would be negative 5 and y would be negative 18. X would be 0, y would be negative 8, and so on and so forth. Okay, you try this one for me. If my x is, if my f of x equals 4 times x minus 7, find each of these if I'm plugging in 5 for x. Ready, set, go. I'll be back in just a second to show you my answers. Okay, so here's what I did. I plugged in 5 and I got 20, and then I subtracted 7 and I got 13. So f of 5 equals 13. You can also write this as a coordinate point, which would be 5 comma 13. If I look over here, negative 6, 4 times negative 6 is negative 24. Take 7 away and I'm at negative 31. So when x is negative 6, y is negative 31. So what about this one? I want you to try this one as well. Okay, if I have 1/4 of x minus 2, what would be my answers? Go ahead and pause the video and try this one. I'll be back in just a second to show you the answers. Okay, so here's what I would have done. I would have taken 1/4 times my negative 4 and gotten 1, and then times the negative 2 would have been negative 3. If I put in negative 2, 1/4 times negative 2 would be a negative half, And a negative half minus 2 is a negative 2.5. If I plug in 0, I'm just subtracting 2, which is negative 2. And if I plug in 4, 4 times a fourth gives me a whole, and 1 minus 2 is negative 1. So sometimes we need to prove that these are solutions to equations. For example, prove that the intersection is a solution to both equations. So what is my intersection point? If I look here, this is 2, 2, right? Because if I look, x is 2, y is 2. So we want to prove that this equation of this line and this equation of this line both have 2, 2 as their solution. So if we plug in negative 3/2 times 2 plus 5, it should equal 2. So think back to when you were multiplying fractions. I can cancel out the 2's and I'm left with negative 3 plus 5 equals 2. Is that a true statement? Yes. So I know that 2, 2 is a solution to this equation. If I plug in a 2 into the x here, and then I plug in a 2 in for y here, and I'm checking, again, this would be like 2 over 1. These cancel each other out, so I'm just left with 1 over 1, which is 1, and 1 plus 1 equals 2, and 2 does, in fact, equal 2. So this one also is a solution to the equation. So both of these, you can prove that this point right here fits into both of these by just plugging it in. Go ahead and try these, and I'll be back in just a second to show you the answers. All right, so if you did number 1, the equation C of D equals $3.50 for D. It represents the cost of renting DVDs as a function. So which of these matches? Basically what we're saying is when I plug in 1, I get $3.50. If I plug in 2, I get 7. If I plug in 3, I get $10.50. And if I plug in 4, I get 14. So that's why that one works. This one, you're plugging in 3, and you get negative 12 plus 2 is negative 10. So the answer is G. And that's all I've got for you today. See you next time.